All right, hello everybody. Welcome to another round of Miss Lambert mini lectures. So this one is going to be focused on solutions. So we're going to talk about what actually is a solution, how can we do some solution stoichiometry, and what's the big deal with them, right? So first things first, what actually is a solution? If you have some sort of substance that becomes dissolved in water, that substance disappears from view. So think about if you had something, you dissolved it in water, you had two things coming together, and it disappears. You're making something that's a mixture. And what type of mixture was that? If it's uniform in distribution, we called it homogeneous. So it forms a homogeneous mixture. And this is also called a solution. So water itself is not a solution. Water is just a pure liquid. A solution must be a mixture. There must be two things that have come together to make a new solution, a mixture. So a solution generally consists of two parts. You've got your solute. Your solute is the substance that is dissolved. And usually this is going to be the substance that's in a smaller quantity. So think about like if you make like powdered lemonade, right? You take a little scoop of powdered lemonade, you put it into a big pitcher of water. That powdered lemonade is the thing that's being dissolved. That's their solute. And it's a smaller quantity because you're just having a little scoop of it. Versus the thing it's being dissolved in my lemonade mixture, it'd be dissolved in water. We would call water our solvent. Your solvent is the substance that the solute is dissolved into, and usually that's the one that's in a greater quantity. So how can we talk about the amount of stuff that's been dissolved into our water? Well, we know that really what we care about in chemistry is being able to relate things in terms of moles, right? Moles is our favorite counting unit. So what we're going to talk about is something called molar concentration. So this is the number of moles of a substance that's dissolved into some volume of your solution. So think about what are the units for moles? It's just moles, right? And what are the units we know for volume? Typically, we're talking about milliliters or liters. Specifically for concentration, we're going to talk about liters. So the units for concentration are moles per liter, or abbreviated MOL over capital L. So in chemistry, we refer to concentration of a solution as the molarity of that solution. So your equation for molarity that you need to know, molarity capital M is equal to the moles of your solute, the thing being dissolved, divided by the liters of your total solution. And we've seen this before, but I just want to point it out. Solution, you can abbreviate as SOLN, just to make it a little bit quicker and easier to write. Okay, so let's think about how we can actually calculate concentration of a solution. So let's say I ask you to determine the molarity of a solution in which you have 0.2 moles of sodium chloride dissolved in 2 liters of water. So to calculate concentration, all you need to know is that molarity is equal to moles over liters, moles over volume. I know my number of moles of sodium chloride I'm dissolving is 0.2. My total amount of solution, well, I just have 2 liters of that water, so I'm going to divide by 2.0 liters. And I'm going to end up with my concentration being 0.1 moles per liter. Or you could write this as 0.1 capital M, where M represents your molarity. The way that you would say this is your solution is 0.1 molar. So moles per liter or 0.1 molar. Either one will work. But let's say instead of giving you moles, I switched it up on you and I asked you to determine the molarity of a solution in which you had 0.2 grams of sodium chloride dissolved in 2 liters of water. Well, now this one just requires one extra step that you all know how to do because you've been doing it since like all the way back to Unit 5, even before then. It just requires simple one-step stoich. right? So if you have 0.20 moles of sodium chloride and you want to convert that, or no, sorry, you're given grams this time, LOL. Okay, so you're given grams of sodium chloride and you want to convert this to moles of sodium chloride. How do we do it? We use molar mass. So if I calculate the molar mass for sodium chloride, which I'm just going to give you for the purposes of these notes, to be 58.44 grams, that's 1 mole of sodium chloride. When you plug this into your calculator, you end up with 0.0034 moles. And I'm asked to calculate molarity, right? So what's the last step? Well, I take my moles, I divide it by the amount of solution I've got, 2.0, and I end up with a solution that is 0.0017 moles per liter, or 0.0017 molar. Either way you write it, totally fine. Same units. So what's the big deal with this? Well, just like when we were talking about thermochemistry and we were talking about enthalpy and being able to use enthalpy as a conversion factor to convert between moles and energy of a chemical reaction, we can use molarity as a new ratio. So unlocked new ratio. All right, so let's say that I've got 30 milliliters of a 2 molar sodium chloride solution, and I'm reacting this with 30 milliliters of a 1.5 molar lead 2 nitrate solution. And the chemical reaction you can see is balanced and given below. So in this problem, I'm asking you to find how many grams of lead 2 chloride precipitate are going to be formed. So stop and think, anytime you're given a SOIC problem, what information are you given? What information are you asked to find out? So we know that we're given some information about both of our reactants. We have 30 milliliters of a 2 molar sodium chloride solution and 30 mils of a 1.5 molar lead nitrate solution. But which one of those substances is actually going to determine how much lead 2 chloride precipitate we can make? That's right, everybody. This is a limiting reactant problem. Anytime we're given information about more than one reactant, gotta figure out which one's gonna run out first. So this is our limiting reactant problem. So the first step to a limiting reactant problem was comparing the amount of moles of each of our reactants that we had in order to determine which one's gonna run out first. Great, easy peasy. Okay, I'm given 30 milliliters of a 2 molar sodium chloride solution. Oh. Well, I don't have any information about moles yet. Is there a way I can find it? Okay, so let's think. What do we know? Well, we know that molarity is equal to moles of your solute divided by liters of solution. And that's great news because there's the unit that I want. So how can I get that unit? Well, if I just do some simple algebra, I can multiply both sides by liters by volume, and I end up with moles on one side. So I can rearrange this equation to tell me that the number of moles of a substance is equal to its molarity times the volume of that substance, which is great because I know volume and I know molarity, so I can figure this out for each of my reacting species. Okay, so I've got moles of NaCl, and I know that the molarity of NaCl is 2 moles per liter. I'm going to write it like this so to make sure my units can cancel. And I need to multiply this by my volume in units of liters to get that thing to cancel. Well, I'm given 30 milliliters, but I need to get that into liters. So how many milliliters are in a liter? We know that milli means thousand, so there are 1,000 milliliters in 1 liter. So we can do some quick moving of that decimal, 1, 2, 3 spaces, because there are 3 zeros in 1,000. And I can say that I now have 0.030 liters of that NaCl solution. So just double check, liters cancel with liters. I end up with units of moles, exactly what I wanted. And I need to figure out if I've got 2 times 0.03, well, 2 times 3 is 6. So 2 times 0.03 must be 0.06 moles of my NaCl solution. Okay, so I'm going to write that up there so I don't forget how much I'm starting with. Okay, now I got to deal with the lead nitrate. Okay, so moles of lead nitrate, PbNO3, 2. Well, I know its molarity is 1.5 moles per liter. How much of it do I have? 30 milliliters, great, which I already converted, 0.030 liters. Double check to make sure my units cancel. Looks good. Okay, 1.5 times 0.03. Well, I know that 15 times 3 is 45, so this must mean that this is 0.045 moles of lead nitrate. All right, so I'm going to, 0.045 moles. Okay, plug that in right there. Great. Okay, next up to a limiting reactant problem, to figure out which one's going to run out first, I have to consider my mole ratios. How much do I use of each of these substances in one reaction? Well, for every 2 moles of NaCl, I use 1 mole of lead nitrate. Okay, so the ratio is not 1 to 1. So what do? Well, I take this number of NaCl and I divide it by 2 so I can accurately compare them. 6 divided by 2 is 3, so I must have 0.03 moles of lead chloride that I'm going to use for every 0.045 moles of lead nitrate. So I'm comparing these two values. Since this one is smaller, what that tells me is that NaCl must be the limiting reactant. Oops. Great. Okay, so now I figured out the limiting reactant. Awesome. What's my next step? Well, my next step is to actually just, now that I have my limiting reactant, I can immediately go to start figuring out what I'm asked to find out in my question, my grams of my lead chloride precipitate. And you might be saying, Miss Lambert, don't we need to do a BCA table? And the answer is, you can, but you don't have to. A BCA table will always work, right? The point of your BCA table is basically a stoichiometry table. It tells you how many moles of stuff you're starting with, how are they going to change in a reaction, how much are you going to be left over with afterward. But it does that for every reacting species. So if I'm only asking you for how much you're going to make of one species at the end of this reaction, I can just do some simple line stoich. I know that I'm starting with 0.06 moles of NaCl, right? That's my limiting reactant. How can I get from moles of one substance to grams of another? Well, I can consult my handy dandy mole map for one, and that tells me that I have to first compare in terms of moles, so I need to get my mole to mole ratio. In my chemical equation, for every 2 moles of NaCl I use, I'm going to make 1 mole of my lead to chloride precipitate. Now to get from moles to mass, I use my molar mass. So in 1 mole of PbCl2, that mass is, hold on, I have it over here, 278.1 grams of PbCl2. Plug this into your calculator, you end up with 8.34 grams of PbCl2, rounded to 3 sig figs. That's how much it should be rounded to. So I'm going to put a box around it. There's my final answer. So we can just do some regular solution stoichiometry now using molarity as a conversion factor, which is great news for us. Okay, so I'm going to have you pause the video here. I have another practice problem for you on the next page. This also combines some thermochemistry into it. So take a second, pause this video, work out the answer to this problem, and then check with the answer key to make sure you've got the right answer. Then you can move on to the next video that's all about making solutions and doing some dilutions.